Hi, everyone. Thank you so much for joining us for today's Pro demonstration. Today, we are going to walk through the new Easier Than Ever Pro that we launched at Formnext. It's still a 1 meter cubed powerhouse, but it allows you to iterate fast, produce faster, and get to market fastest. Our two speakers there are actually sitting right in front of the new Pro, and they are Jan Hoffman, who is the product manager for the Pro. Super smart guy, knows everything there is to know about the Pro, so feel free to ask any questions you might have. And Marco Mattia Cristofori is the head of our product marketing as well, and he is going to walk through some features and some applications as well. Just a little housekeeping before I turn it over to those guys. In the side panel, there's a chat, and I will be chatting with you guys throughout the webinar. I'll be launching some polls. You'll be able to download some spec sheets and some brochures, as well as some fun and other interactions. You can also ask questions there, so feel free to chat me those. And at the end, we'll have saved some time to ask as many of those as we can. And if we can't get to them all, I promise we will follow up with you after. And so with that, I am going to turn it over to you guys.
Abe, thank you very much. So let's start this little demonstration. First of all, we'd like to talk a bit about BigRep in general, right? BigRep has currently 3 printers out there in the market, and we have more than 600 actually sold, and we have around 50 plus among partners and resellers around the world. So we have the headquarters where we currently are here in Berlin. We have another office in Boston and one in Singapore. So I would say we're pretty global, right? About the products, for the people who couldn't make it to Formnext, that was obviously visible at the booth. We have, as mentioned, 3 products, but we kind of have developed them for 2 different, let's say, users. We have the innovation product line with our BigRep 1, which during Formnext we presented the 4th generation of the one. It's not going to be the topic of today, but a machine of still 1 cubic meter, very much used for prototyping, for sand casting, for concrete formwork. So for really people starting into large-scale 3D printers and starting to try to bring this technology into their manufacturing process. While on the other side, we have 2 products that are similar but different sides, the BigRep Studio and the BigRep Pro. The BigRep Studio is of 1000 by 500 by 500 millimeter build volume. So we're talking about 1/4 of the volume of the Pro. And then the BigRep Pro, which, and also this one, we introduced the Formnext, the new generation. So we're talking about the 2nd generation of the BigRep Pro, again, 1 cubic meter of printer, and it's going to be the topic of today. There is probably no better way to introduce a new product than with a video. So first of all, we're going to show you the promo video that we used to launch the 2nd generation of the BigRep Pro. I always feel like one. So for the people who might already know the BigRep Pro, the first generation of the Pro, probably you saw some new things. For the people who don't know already the BigRep Pro, we prepared this little slide to actually guide you through the process or to all the features that this machine have. We're gonna guide you through each and any of them. First of all, the most basic, we're working, our technology is FFF. As you might know, the additive manufacturing, it's pretty big. There are several technology out there. The technology we use is FFF. So we basically work, first of all, with only polymers. So we're talking about thermoplastic, and we work with layers. So it's an additive technology, and we extrude layer by layers the parts that want to be manufactured. But getting into a bit more the actual spec of the machine, one of the main feature is definitely the 1 cubic, right, meter build volume. It's pretty unique. It's big and helps us to do really a lot of things, not just print, again, large parts, but you can really print also batch production, right? So you can really print a lot of smaller parts. And this gives you a lot of flexibility, right? Because you can really use this agile hardware as you actually need. We focus on different targets, but the industry, you know, it's so big that at the end of the day, there are always people that comes up with new things, and we discover also with new customers every time. But we really focus on prototypes and functional prototyping. But not just that, also the one of the biggest application for this machine is actually tooling, jigs, and fixture. So this machine, in the world of automotive, having this machine on the shop floor can really change things, can really speed up the process. And I'm talking about several things, just not only jigs and normal fixture, but, you know, quality assurance, CMM. There is a lot of things that this machine can print and support with. There is the wall pattern molds in different industries, so it's pretty generic, but of course it goes, like we mentioned before, for the one, of course you can also print patterns for sand casting or concrete formwork, but here you can push a bit more thanks to the special materials that this machine can print. We can also go into the wall of carbon fiber. So we can do print molds for laminates, or we can print plugs to then make laminates, molds, glass fiber, etc., etc. And then there is the whole end-use part, as you can see in the picture. We have, of course, a lot of customers doing that. In the automotive, happens a lot, but also in other industries that really push, you know, the boundary at the end of the day of manufacturing, when you can do these large-scale end-use parts for your products. Here, just a picture of one of these huge smart fixture from one of our customer, WAT. It's one of my favorite pieces. Actually, with this one, we exhibited at Formnext as well, because it's really a tool that is very complex to manufacture otherwise. So here it embraces all the, you know, the potential of this technology and the large scale combined with this technology. So this is a smart fixture because it combines not only the parts itself, but, you know, a lot of probes, not only the printed parts, but a lot of probes to take, you know, to make sure that the frame where this part is used actually respect the quality enough to then go and don't actually stop the work process, right? Let's then go to the new features of the Pro as well. And here I pass the word to Jan.
Thank you, Marco. And I'm quite happy to talk about the new features. We were really busy in the past months and half year and more to make the Pro really a lot more usable, a lot more accessible. And we created what we call JUMPSTART. It allows you to skip the hassle and just print. And to achieve that, I'm going to talk about three main aspects which we focused on. The first one is what we call the switch plate, and you saw that in the video before. That is a surface that helps us. Just stay here. Thank you. That helps us first of all have a nice process for having the part on the surface and for part removal. On the right side, you see the lock stage. Lock stage is what allows us to fasten the extruder to the portal, to the moving part, moves it in the build volume. And in the middle is really the brain of the whole thing. We call that the MXT control system. That is where all the algorithms, all the magic, all the sensing, adaptation to the printing happens. And we're going to go into some more detail here. Again, why are we doing this? It's really about dual extrusion. Dual extrusion is the really the most challenging of applications, but it's also the one that makes for the most versatility. Without dual extrusion, you cannot print with support material, and then you have to actually design for AM. While we want people to understand that design for AM is very important, there always are applications where you just have to be able to print your injection molding part, or the part is very complex, and having the ability to have easy dual extrusion here allows you to basically, it gives you a very high design freedom for your part. And there is the switch plate aspect of the whole process, which is interesting in so many ways, and improves usability a lot. Before, we had a system where you had to actually apply glue to the build plate before you printed, and it was messy and not very nice. Now we have a print surface that has the amazing ability to, when it heats up, it becomes sticky, and it allows the part to stick very strong to the build surface, which makes sure that it doesn't warp of the part, and the both the support material and the actual material stick to it really well. As it cools down, at the end of a print, it loses this feature of being sticky, and you see here, you can just lift it off the plate. All you have to do is slip the plate at the corner a little bit, and that essentially pops the part of the plate, and you can just take it out. This is a big time saver. It allows you to, you don't have to go through a lengthy process of part removal. The whole thing is a lot cleaner. You don't have glue sticking on the surface that afterwards you have to remove. Also, more often than not, you can destroy the part while trying to remove it. Little parts break off, and here it just pops off. What you see in the video, I don't know if we covered that elsewhere, is a part that has on the right is printed. I think this is printed in high temp CF material, but the thing that I want to point out is that the support material is actually water soluble. So in this case, you could break it off easily at the bottom, but if you have more complex structures that are not so easy to reach with tools, water soluble support is really what we want. Next slide. Sure. And there's a lock stage. For dual extrusion to work perfectly, what you need is you have to have a highly accurate portal, and you have to be very, you have the way that the extruder is moved in 3D space has to be super accurate for that, especially when you do dual extrusion, where one extruder is essentially printing right next or on top of what the other extruder just printed. And therefore, we develop the lock stage. The lock stage is a way for placing the extruder on the portal and replacing it if needed. And it ensures that the positioning in space is highly precise. And you see it's precision machined aluminum here in the back. And just from the way that it's mounted, you already get a very high precision.
I will show the quality.
Do we have more? Yeah, let's. I'm going to want to. Do we have a sensor picture? No. Okay. I'm going to talk about the MXT control for a little bit here. MXT control is the control system, is really the brains of the whole thing. So there are algorithms in there that ensure that what I just said, the way that the material is placed at very high precision, that the machine basically doesn't require any human intervention and very little setup. We don't need an operator here anymore that goes through a lengthy process of setting up the machine, of cleaning the build plate, of setting up the extruders. The machine does everything for you. We achieve that by having the MXT control system. It is built around the industrial Bosch components that we're using, but we've put a lot of really smart things into it. We added it, and that really makes this dual extrusion experience a lot smoother. And you can see here the quality that we're achieving. This is a very complex part that we printed. Wouldn't be possible to print many of the features without support, and it came out super nice. And yeah,
It's beautiful that you bypass the word manual calibration. At the end of the day, it just goes like you say. It's wonderful.
let's also talk about the Precision Motions portal. That is here. Next one, please.
Mm-hmm.
It's the second generation. So this is really the biggest change in the machine that you can see beside the MXT controls. This is the physical manifestation of the precision. So we wanted to achieve a system that is very precise, and the Precision Motions portal helps us there. We made it even stronger than before. It's, as I said, built around Bosch Rex rod components. The motors, the control system, everything is industrial grade, including safety mechanisms that ensure that it stops when you open the doors. And this keeps vibrations to the minimum. Vibrations you can see in the print result, and that's why it's important to minimize them. It's the part that moves the stage and the extruders around. It is able to do that at much higher speeds than the previous generation machine. And all of this, in the end, translates into achievable accuracy of the part. For the BigRep Pro, we have an achievable accuracy of plus minus 0.2 millimeters. That is very much up there in the ballpark of what other high-end competitors are offering. There are machines that are a little bit higher in their achievable accuracy, but they also cost a lot more. This is also something that we're constantly improving. The specs which make this possible is of the Precision Motions portal is acceleration of 2 meters per second square, which is up from what we had before. The control system has an accuracy which is even higher than what we just looked at, and the whole system also has a really high repeatability.
Great. So before passing through the first, I loved how you call the physical manifestation of precision, which is a very accurate way to describe the portal. You're gonna see it after, but it's definitely beautiful. About the wall jumpstart is I think it's really amazing how you guys actually solved a lot of the things that, you know, I mean, at the end of the day is what users want, right? That's what you really focus on. And people realize also, seeing it at Formnext, right, how easy it was just to start such a dual extrusion complex print in a matter of like minutes, because the machine does it. And then the pop-off, which maybe we saw it, right? Maybe with desktop printer out there, flexible plate, you could have seen it already smaller, but when you see it in large scale and behaving in that way, it's just beautiful. It's just part that pops, and you just take it off and it's like, oh, we're ready to start again the print, and people are like, wow, that's it's definitely impressive to see. But that's not all. We also have a full new material that comes now with the Pro. We're talking about PA12CF, which was a material which was, again, same, really requested by our users. So we really focus on this one. As the machine itself, of course, we have a video in BigRep style to introduce this material. So enjoy it. This was definitely a challenge that has been accepted by multiple people, because at Formnext, multiple people came with the idea of, hey, I want to try to break it, and nobody could. Actually, it was interesting. That specific part that you saw, it ended up with a lot of people smashing it on the floor loudly and hardly. Absolutely nothing happened. There was a little delamination on the corner, but really people pushed hard. Then we had to stop because the security didn't like it, but it was definitely fun. This material is amazing, guys. You can see already here just a comparison with our we just compare it with our portfolio. People might be familiar with our ProHT high temp or high temp CF, which are more material that we're already out there. So the tensile strength is going up, and this is again, it's just very strong. It prints super well, and the surface quality is just insane. We had this part which we show there at Formnext as well. I'm gonna just turn on the audio because I didn't know how to do it on the PowerPoint. This you can see a bit of how the surface looks like. The video, I hope it actually gives an actual reality of how it looked like. It was beautiful to see. Several people came and asked, oh, what did you use to post-process the surface on this part? Like, did you guys sand it? Did you guys do, like, I don't know, tumbling or whatever? And I was like, no, this came just out of the printer like this, and people were like, oh my gosh, this is impressive. I mean, it's a large scale printer. We're not talking even like two small nozzles. It's not 0.3, 0.4, it's a 0.6 nozzle with a 0.3 layer height. The print that you see there, it's 3.5 kilos roundabout. It took 48 hours. Again, with we're talking about 0.3 layer height. So even the speed, the output, and here you see all the things that Jan mentioned before. The manifestation of physical manifestation of the portal, how it supports even more. This is one among the filament that the machine supports. I mean, our portfolio is always growing. You will see several fiber-filled material coming in the next months, in the next quarter. We're always developing new one, but always keep in mind that also BigRep is an open system. So you can use third-party filament on the machine, you know, at your convenience, whatever you prefer. Among the one you see, of course, you see SAA, PTG, PA666, which was the one we printed actually at Formnext. We had these live prints for like 6 days in a row in dual extrusion with PA666 and BBH, the water-soluble solution we offer. And again, seeing just running it smoothly, you know, without any issue. It's just beautiful, because that's how it's supposed to be, right? And that's what we focus on, make it simple and easier than ever. Latest thing I want to go through, everything is amazing, hardware, software solution inside the machine, but of course there is always the stage of, from my CAD file, how do I get my printed part? And that's where Blade comes in, right? That's our proprietary software for slicing. It's really built to make large-scale printers easier. When you go small desktop, you have less things to consider. When you go bigger, of course, there are more things that you need to consider, and Blade really helps you to make it happen. First of all, it's super optimized for large scale, also engine-wise, so it's it slices fast, even though we're talking about sometimes mesh with, I don't know, millions and millions of faces. But not just that, as mentioned before, big printers is not just big prints. It also means a lot of smaller prints, and here is where also Blade comes super handy. It has a lot of function to just simply, you know, drop in a part and then multiply it and you know, fill the bed to print in batch production. This is something that some people know, but in general, printing multiple parts is not just about printing them. Of course, you can printing them all together in the same time, but when you have a large-scale printer, you can also print several first on the front line and then go backward and start printing the second line once the first one is done. And this also helps because you can, you know, when the second line starts, you can pause the print and take off already your parts out. So you don't need to wait until all the parts are finished. And this sometimes comes super handy if you need to rush a production or something. Blade, of course, this is a bit of interface of Blade, and Blade is completely for free. Of course, you can just go to bigrep.com/blade. You can download it and you can start, you know, just playing with it if you're familiar with slicing in general. So you can check a bit. You can run some simulation. You will find all our machine, the one we showed before, the Pro, the One, the Studio, they're all there with all our materials there, with all the profile, with different layer height. So you can really run some simulation. If you are not familiar with slicing, well, of course, you have these beautiful videos that we offer, this training. They're free, they're there. And if you watch both of them, you will really become a 3D print expert, which is pretty cool. Latest thing, let's just go through the spec. And
yes, so let me highlight some of the things that maybe I didn't talk about in too much detail before. One of the things is the extruder throughput that we're getting from the machine is up to 130 grams per hour. That allows you to print way over 2 kilos per day, which is pretty amazing, I think. We have the machines come with extruders that can take a nozzle diameter of 0.6 millimeters and 1 millimeter. The 0.6 millimeter we're using with the 0.3 millimeter layer height to produce end-use parts that require high surface quality and high surface resolution. The 1.0 millimeter is for faster prints, and we usually use that with the 0.6 millimeter layer height. There's always a trade-off how much you can get away with maybe not the highest surface resolution, and for jigs and fixtures generally this is not a requirement to have super nice surfaces, but for end-use parts it certainly is, and it also depends on what kind of post-processing you're willing to do. Sometimes it's easier to post-process than to or quicker to post-process a part than to wait for a high resolution print to finish. In terms of layer height, this is we're actually extending that. It becomes a little bit more variable so that it can actually, for the parts that require that super high resolution, you can go below the 0.3 millimeter. Talked about the accuracy before. Yeah, and I think that's there. Maybe one thing to add also is the material storage. It doesn't sound like something that is very exciting, but for people that have used 3D printers before, there are certain materials which are very prone to picking up humidity from the environment, making the material degrade and not print nice. Therefore, we have the keep dry filament chambers, which essentially is sealed environments for those materials. I mentioned the water soluble support before, and which is obviously, if it's water soluble, it's prone to picking up moisture. But also materials, engineering grade materials such as PA666 nylon. That is something that you can find lots of videos on the internet of material that was just left out in the air and then printed, and the quality is just going down really badly. So to remedy that, we have those two keep dry chambers, and with BigRep we're printing large parts, so you can equip those with 8 kilogram spools,
which is pretty amazing, right?
which is pretty amazing. And
keep in mind that
pretty
always,
big,
right? You can use the 8 kilos. That's more a pro tip we got from our customers, right? You can use the dual extrusion, of course, for two different material. You can do water soluble for a support, or you can mix two, I don't know, material with two mechanical different properties, or as one of our customers said, you can use dual extrusion to print 16 kilos, right? Because you can use T0, like if you can cut your STL and you slice it, and you see that the STL is around 8 kilos, the half, and the second half 8 kilos. You can print, now that you have this wall JUMPSTART helping you with the dual extrusion and everything, you can also print with both extruder the same material and print up to 16 kilos without even the need of changing spool. Of course, there is a sensor that whenever goes out of filament trigger, so you can easily do it with the same. But if you really want to be like a hands-free, then that's another way to use dual extrusion. Shall we do a little tour? Want to check the printer?
absolutely.
Let's ask a bit of a support here. I'm gonna take you. Hopla, taking with us. Let's see. Great. Hopla.
So should we maybe start with the part first?
Sure.
Because we're just talking about the dual extrusion and those materials. So what you see here is a fixture that one of our automotive clients is using, and what you see is this is printed in PA666. PA666 has very nice mechanical properties. It is very strong also in the Z direction. So you have sometimes what happens with 3D printing is that you have delamination. With nylon, you really don't have that at all. It's a very shiny material, therefore you see all of the printing. We actually like that a lot here. It's very different from what Marco was showing before on the on the PA12 part. You don't really see that. It's much more matte, and it's a very different finish. But here, this is a jade. It doesn't really matter how it looks. Very high resolution print though. And you see here, this is the support material. You can take this off easily. This comes off. And for those parts which are a little bit harder to reach, like here, you can and potentially holes, inserts. You can just submerge it in water and it will come out nicely. And this is a print that in that high resolution we printed at Formnext. This is the actual part that we printed at Formnext. Took around what, 4 days. We started on the evening before, and it finished while the trade show was still going on. And yeah, and this is also, we just before this meeting, before this webinar, we started the print again on the machine. And you can see it print the first layer. This again is the machine was, this is also the machine that was at the trade show. We had Fernando come in the morning here, set it up. Took about, well, it took a while. The most time was spent collecting the tools for it.
To take off all the plastic around, right? The wrap.
And yeah, and take off the bubble wrap around it. After that, the machine was up and running in something, I don't know, 30 minutes, 45 minutes.
including heating bed and everything, right?
Heating, exactly. Heating the bed is usually something that takes the most time because this print is running at 80 degrees. And it was just essentially push play. All of the MXC controls is doing all the sensing, all the setting up of extruders and parameters by itself, and it's printing here the first layer. This is the surface that we are using for nylon-based materials.
Yeah, right. Because on the image when we show the switch plate, you saw two different colors, right? So it's important to highlight that. Of course, it's not just the color; it's because they're made for different materials, right? The black surface is for PA-based material. The other one that you saw is more for PLA-based material. So of course, you can easily change them accordingly to what you prefer to print. And here you can see the beautiful portal that Jan was mentioning about. Which another nice thing is that there is no front bar. And this helps you even more whenever you want to switch plate. You can easily take it off also from the front door. So it comes super handy for the work process. Again, the whole idea is just to make it easier for users to use.
Yeah, actually, this is something that we didn't mention before. The switch plate, of course, I mean, one of the good things about it is that you can lift it up and then the part usually detaches. However, if you don't want to wait for the whole print bed to cool down, you can just take it out, take on your work gloves and take out the whole switch plate. You can put it in another and you're back up running in no time here. And then you can let the surface just sit here, cool down, and you can do all the things that in the confined area of the build volume you wouldn't want to do, like bend it if needed. But so far, like with all the big parts, there is no problems removing the parts.
Snaps. It's beautiful snap. It's a beautiful sound. Okay. Go back with the sharing of the screen. Thanks, Jan, for the little tour. Let me try to go to the next slide. Well, just while Itai set it up, thanks. The camera, of course, all the information that you saw about BigRep PRO spec sheet included. Everything can be found on BigRep.com. You will find also the product page of the one is updated to the new version, as mentioned, the generation 4. So just go there, and there is every information you might need. Okay, Abe, I think I'll pass the word to you again.
Yeah, so we did get some questions came in throughout that great overview. And I think it was great, Jan, when you picked the part up, because I think sometimes the pictures I hear feedback that they're deceiving. You can't really tell how big the part is, but you're a very tall man and you were holding that part and it looked ginormous. So I think that really helped, set the stage there. But a couple of questions did come in about average cost per part when printing a part. And I know we're not going to talk about the price of the printer. If you want to know that, feel free to send me a quick chat there, or we can follow up with you after. But just in terms of cost per part, what's the average range of some of these parts that we can produce?
Take over. I prefer me to answer. You do it. Okay. But I mean, it really depends, of course, on the size, right? That's the first thing, and on the application itself, because then it's about the material. So material and size really can change this. But in general, it's again, beside the printing time, that at the end of the day is once you have the machine, it doesn't really matter a lot. It's just about the material itself, and the price you can see also on our website. You can find out the price, and that helps you understand more or less how much a part will cost. But again, being also an open system to third-party materials, if you don't want to use our filament, you can use external filament. But in general, well, to be honest, seeing up in the market, the price of our filament are really, really convenient. So I guess that helps a lot also to print a large scale part. And of course, if you then compare with other material, like with aluminum, if you're talking about a comparison with a CNC mold for a prototype of a carbon fiber part, I don't think there is no really need to even talk about it, right? I mean, CNCing a full, even a 50 by 50 by 50 centimeter aluminum part to make a couple of carbon fiber parts to do a prototype, compared with just printing them in a thermoplastic. It's not just about money, it's about a lot of time saving, it's about a lot of hassle, because at the end of the day, additive on this one comes very handy.
Absolutely. And we have one of our customers that we're like partnering more closely in automotive, where we see not only exactly what Marco was saying there, the comparison to aluminum parts, and there, not only do you have the cost savings, but you also have the time to part savings. You get your part a lot quicker, and you have weight savings. That is the other thing when you talk about cost per part, and if you compare that to say an aluminum part, it's very, very different, because you don't need to have solid parts.
Exactly.
You get very strong parts with which are a lot lighter, and the internal structures are they're strong enough to your specification.
And you can customize them as well, which gives this thing. I mean, just keeping the flow of the discussion, because like we're talking one of our customers in the sand casting, right? I mean, in that case, not aluminum, it's wood, and you see the difference of having large scale pattern from additive versus subtractive, where subtractive, you're talking about wood in this case. And another thing is just the logistic of, we're talking about 1 cubic meter printing from 0 to the part, or 1 cubic meter starting from a 1 cubic meter of wood, that as a blank that you need to subtract. So the difference of having a couple of filaments stored in I don't know, in a place, compared with having someone carrying around a 1 cubic meter of full wood, that's definitely a big difference. So that's one helps as well on the price.
Great. Okay, we got a couple of questions about switch plate. First one made me laugh. Do I really not need to use glue anymore?
You don't. In fact, you shouldn't, because that's not good for the surface.
Okay.
So compared to something like Kapton, that we're also still going to be offering, it is something that ages well, if you want. So it's not really consumable. It's compared to Kapton, which depending on your use, you have to replace after a few months.
Of course.
Okay, next one is, how long after a print finishes can you remove it from the plate? You mentioned a little bit of cooling down. Is there a range or a?
There is in general, there's the cool down of the part that you have to consider. That's actually something where I sometimes am too eager to hold the part in my hands, and then the part itself is still hot and deforms a little bit. So generally, it's better to let it cool down. I would say probably something like 30 to 50 minutes of cool down is sufficient. And here again, you can take out the part. You can also open the doors of the printer to the side to have it cool down faster. But yeah, beware that the part itself doesn't warp.
Yeah, of course. I mean, depends. I would say also, I will add maybe probably the ratio, right? If it's a very big print, like with a big surface on the bed, yes, I will definitely fully wait until the cool down, because you don't want the plastic to still be, flexible and then warp. But if you have a ratio where it's much taller and the surface is super small, well, I would be probably eager a bit more to then just, you can just take it off easily without waiting too much.
Okay, and we talked a lot about this, and how easy it is to start a print. But if you had to tell somebody from the time you get your file to the time it's now printing there, how long does that take?
I have a beautiful answer, but if you want, first go with the technical answer.
Right now, I would say the longest time it takes is for the bed to heat up. All of the other setup routines and algorithms you hardly notice them. So it's really when you're done in Blade and upload it to the machine, really you're set to go. And also, one of the big benefits of the algorithms that we have there is that they are all doing their measurements in the operating environment, which is something that manually is, if you do that manually, is sometimes really hard to do, because if you have to handle a print bed that is 80 or 90 degrees hot, then you have to wear gloves, and you it's not a nice experience, and you don't, basically you just don't have to do that anymore.
Exactly.
But I want to hear your nice.
No,
Yeah, now let's hear Marco's answer.
I mean, the idea was to really focus on, like you said, on users, right? So we wanted to, yes, like on some other large scale printers, of course, you need to have some skill set, but here we really wanted to make it like, okay, once you have the G code, once you went through the Blade, then it should be easy to start the manufacturing process. So we really, I'm not going to make any names, I'm not going to do any names, but we really use people in the company which were maybe not familiar at all with 3D printing, or let's say in various years never used the printers in BigRep, and it was just so gratifying at the end of the day to see how easy it was, because it's just about letting the machine, so it's fast and it's easy. It's both of them.
Great. All right, we got 2 more questions before we kind of wrap things up here. One was, how hot can the bed get?
The bed can go up to 100 degrees.
So 100 degrees Celsius.
Yeah.
Great. Okay.
We're not using it at that temperature right now. I think the highest temperature is 85 that one of our materials needs. But if your material requires more than that, it goes up to 100.
Great. And one of my favorite questions that came in is, when can we get it?
It's available now.
Great. All right. Well, I'm sorry if we didn't get to your question, but we will, like I said, we will follow up with you guys after. And we did talk a little bit about cost per part. Mark, if you want to go to that next slide there. We came up with this great website and concept, Let Us Prove It to You, PRO, like prove it to you, if you want to say it like that. But you can simply upload a part there and we will analyze it for you. We will talk cost of that part, the material recommendations. You can just scan this here, actually, or you can go to that website there. But we can help you take a look at a part, and it's a great way to actually kind of see how the Pro could really affect your everyday, and kind of how the guys talked about comparison to your current technology that you might be using, or even another manufacturing process. So this is a great resource. So I hope to see lots of parts come in after this webinar. And with that, feel free to follow us online. We post a lot of great case studies, a lot of cool videos like the ones you saw here during this presentation. But yeah, be sure to connect with us and follow us and stay up to date on all our great use cases and things like that. And so with that, I appreciate that you guys took time out of your day to spend a little time with us. Thank you to Marco and Jan for all of that great information on the new generation of the Pro. I hope you all enjoyed it. And I hope you all also see how easy it is to use now. And so with that, I'd like to thank all of you for joining, and thank you guys for your great presentation. And I hope to see you soon. Go BigRep.
Okay, thank you, everyone.
Thank you. Bye-bye.